Hi guys, welcome back to Baka Code. And now here in this video we discuss about operators. See, this is very important. First we'll discuss about arithmetic operators. See what are arithmetic operators are. See, for example, let's say C equal to A plus B. And these are known as operands. This plus equal to, these are operators. C, A, B, these are operands. This is the basic terminology. For example, let's say arithmetic operators are, some basic math, that's it. C equal to A plus B, or A equal to C minus B, and C equal to A into B, C equal to A divided by B, A by B. These are some basic math, and you all know this. What new here is modulus. Modulus is represented by this. If C equal to A modulus B, this means that the remainder, when A is divided by B, the remainder is given. For example, let's say A is 5 and B is 2. 5 divided by 2, the remainder is 1, and C is equal to 1 here. Okay, modulus function returns remainder. This is important. Modulus gives the remainder. For example, let's say what is 10 modulus 2? That is 0, right? Because the remainder when 10 is divided by 2 is 0, right? Yeah. When 5, the modulus of 5 divided by 2 is 1. Modulus of 5 divided by 3 is 2. Yeah, that's it. C equal to A modulus B means if A is divided by B, then the remainder is what? Modulus. Okay, yeah. Now let's see the implementation of this. Yeah, see, hash include IO stream using namespace std int main return 0. This is the basic structure of C++. I'm now trying to use the modulus function. See, modulus function examples for not modulus function, example for arithmetic operators. And now yeah, I've given a heading, and now I have to comment it out, right? Yeah, I've said you comment in what is commenting out in your first video. Yeah, I've commented out. And then next, first of all, I'll take arithmetic operators. In arithmetic operators, I'll take add function. I'll initialize int a equal to 10, and next comma b equal to 2. See, you can write like this. Okay, int a equal to 10. See this, int a equal to 10, and comma, if you put a comma in between, it reads like b is also a variable of int data type. Okay, and you can write this. This is actually a shorthand notation. The full-fledged notation is int b equal to 2, right? Then next, int c, right? For addition, c out adding, adding. The next c equal to a plus b, that's it, and you have to output c. Okay, what is the expected output is, it will print adding, after that space, and it will print c, and then the cursor moves to next line, And now subtracting, see out subtraction, then see out, no wait, next c equal to a minus b. Okay, then next see out c and then, so this gives subtraction. The next c multiplication, c equal to a star b. See, multiplication is denoted by star. Okay, the next see out multiplication, see out see, next division, c equal to a by b. See, I've said already, if 10 divided by 2 is how much? It's 5. If it is like that, 11 divided by 2, that is 2.5, but we are taking c as an int, that is why it will output as 2. Okay, if we have taken c, for suppose if we have taken a equal to 5, b equal to 2, I've I want to use division, arithmetic division, so I'll give c equal to a divided by b, and now this gives the output as c as not 2.5, it will give c equal to 2, because c I have declared c data type as int, not float. Okay, yeah, c divided by d, a divided by b, c out division, c out division, next c out c and then. Okay, now let's see the answer. C, yeah, now we'll see we are running it. See, after I've written some error in this, I've written some error. See, I have to put 2 symbols. Okay, yeah, that's it. See, adding 12, subtraction 8, multiplication 20, division 5. Got that? That's it. Yeah, I've forgotten to write modulus function. Okay, and now let's see. uh, c equal to a percent, you have to use modulus as percentage symbol. Okay, modulus is given by percentage b, c equal to a modulus b, then now c out modulus c out c and l. See, you are in every lecture, if you see, you are used to this one, you are giving spaces, you are giving n lines. That's what practice is. If you write code for many problems, you will practice everything. You don't have to see, if you see a lecture, you don't have to learn everything from that. Gradually you learn everything. Okay, run. Yeah, modulus is 0, because modulus is what reminder. Okay, yeah, These are arithmetic operators. Then comes, we have completed all arithmetic operators. Then comes, no, we have not completed arithmetic operators. There are two more: increment and decrement. See, in increment or decrement also there are two more types: pre-increment, post-increment, and pre-decrement and post-decrement. Okay. See, what is pre-increment? What is, first of all, I'll explain what increment is. If you take int a equal to 10, you have initialized a variable a of integer data type as 10, and then you have incremented this. This is post increment. Actually, you have incremented this. See, what does this mean? A 10 plus plus, you are increasing 10 by 1, that means it is 11. But see, the value here is not 11. When the compiler sees a again in the code, then it increments 1 to it, because see, a post increment, it is incrementing after that. Already there is a present which is of value 10, and you are incrementing after that. Okay, 10 plus 1. For example, this is not like 10 plus 1, 10 plus 1. For example, for suppose thing like plus 1 is in air, it is roaming around in air. Post increment means, the best example I am giving, if you are post incrementing like this, if a equal to 10, if a plus plus, thing a equal to 10 is here, and plus 1, plus plus means thing like plus 1, it is hanging around in air, it is roaming in air. When the compiler sees again like c equal to a plus b, and now when the compiler meet a again, then it increments a to it. Then now the value of a is 11 here, c equal to 11 plus b here. Okay, see, int a equal to 10, int b equal to 2, int c. Now I am post incrementing a plus plus. Here the value of a is 10 only, because plus 1 is in air, it is roaming around in air. Here it is not added. And when the compiler says I have given c equal to a plus b, when the compiler meets a again, it increments. This 1 plus 1 is added to this before, after getting here. Okay, c equal to 10 plus 1 plus b. Now c equal to 11 plus b. This is post increment. For example, I'll write a code for this. Okay, a equal to 10, c out a plus plus, and I'll write another code, a equal to 10, a plus plus, c out a. See, you will understand very clearly from this example. See, here the value of this is 10, because plus 1 is in air, the compiler doesn't met a again, so the plus 1 is in air, it is roaming around in air. Here the value of a, here the value of this is 10 only. Here the output will be 10, output is 10. But here see, a plus plus, when you given a plus plus, when you have incremented, when you have post incremented a equal to 10 and plus 1 is hanging around in air, when the compiler sees a again, it adds. Now a becomes 11, now the output is 11. Now let's see practically writing a code. Hash include IO stream using namespace std int main return 0. Now let's see, int a equal to 10, I have given 10, a equal to 10. I have now c out a plus plus and del. then again int of cout a plus plus, then cout a. Let's see this. 10 11. See the magic. 10 11. I'll explain you this. I'll explain you this. I'll copy the same code in my notebook. I'll copy this. See, wait. See this. See, I'm writing it again. Yeah, it is too small. Int a equal to 10. Cout a plus plus and l. I've copied the same code here. Cout a. See, when I am post incrementing here, the value of this is 10 only, because I have said that if you are post incrementing a plus plus means a will be here, plus 1 is hanging around in air. But when the compiler sees a again, it increments it. It adds plus 1 to it. See, initially I've printed a plus plus. This value is 10 because plus 1 is hanging around in air. Then in second time when I've printed cout a, the compiler met a again, so it incremented this. That is why this output is 10, this output is 11. I think you have understood this. Similarly, post increment, we have to discuss pre-increment. Int a equal to 10 plus a. Here initially plus 1 is added to a. Okay, for example, this value is 11 here only, nothing in here like post increment. Plus 1 is added to a. That's it, directly. You can, for example, cout plus a and l. This value will be 11. And see, I'll make you clear with an example. Int a equal to 10, cout plus a and l. There is nothing like hanging around in air. Yeah, I've said that for an example. It is easy to understand if you think like that. Okay, see, the output is 11. It incremented it is a pre-order incrementing. Okay, plus a, it adds plus 1 to a. That's it. It is very easy to understand. And now let's see, same like decrement, pre-decrement and post decrement. If you use post decrement, if a equal to 10, you have post incremented this value is 10, minus 1 is hanging around in air, and when the compiler sees a again, now this 1 will be deducted from this is 9 enough. Okay, did you get that? As simple as that. As what I have said, pre-increment, post-increment, that same laws also repeat for this. And pre-decrement is the compiler no hanging around in air, directly it reduces 1. It reduces by 1. Let's see code for that. Okay, you'll better understand it very clearly. I think this explanation is enough. Int a equal to 10 and post decrement cout, no, not like this. Okay, wait, cout a minus, this is post decrement, and cout a. see here I'm post decrementing this. That means here the value is 10 itself, and here when the compiler sees a again, the value is decremented, 1 is decremented from this. And now similarly pre-increment, like if int a equal to 10, then cout minus minus a, the compiler decrements here itself, no hanging around in here, and l and cout a and l. Now let's run the code. Compilation error. Redeclaration of int a. Yes, I've redeclared int a. See, this is an error, and this is the time I have to say you shouldn't redeclare any data type again. You have to initialize, that's it. See, I have declared a as an integer data type here, and I am again redeclaring as int. No, this is wrong. This is wrong. You have to avoid this. You have to, for example, I want, why I have declared a again is, see here the value of a is entirely different. It is 11 now, and I've taken like a itself as 11. No, you'll confuse that. That is why I've starting a, I've started a with 10. Okay, no, it shouldn't be redeclared. I've reinitialized a. You shouldn't declare a. Declaring is you're changing a data type. Okay, that's error. And now I'll run it. We shouldn't redeclare. We can reinitialize. We can put a equal to 22 also. See, 10 9 9 9. This is post decrement 10. Here minus 1 is hanging around in air. Okay, minus 1 is roaming around in air. Here the value is 10, and next when the compiler see a again, it decrements. Here what happened is minus 1 is deducted directly because it is a pre-decrement operator, and the value here is 9, and the value of a is 9. That is why here the value of a is 9. Okay, did you get that? You might have a doubt like a is 10 and it should be 10. No, here the value of a is 9. Okay, that is why here the value of a is 9. Okay, that's for the day, guys, and in next video we'll have some problems on this pre-increment, post increment, pre-decrement and post decrement. We'll take some problems and we can do that. That's it for the video, guys. Bye.